Good morning, and today we're continuing with our equivalent fractions, and we're going to be using number lines and a fraction wall to help us solve problems. Let's look at discover them. Two problems today. Remember, you're going to shout out the answer as soon as you know it. See how quick you get the answer. Looking at Rena's first. Rena says, I will make a fraction that is equivalent to half. Now, if we look what number she's got to work with, the number she's going to make the fractions with is 3, 4, 5 and 6. She's already got half there. She's got to find the equivalent to. We're just doing these numbers. She can only use those numbers to pop there. Some of you might have already got it. If not, let's look and let's share this number line. Number line. It's not a number line. What is it? Yeah, fraction wall. So this is our fraction wall, which is going to help us, and it's been put into halves, thirds, quarters and sixths, and we can see why it's been put into those, because some of those numbers are there. If we want equivalent to half, well, we've got half there, we can see that, so it can't be thirds because it's halfway between that, and we can't have that. It's got to match it completely. Could be quarters, look, let me see, because that would go there. So if it's quarters, it would be 2 quarters. We've got the 4, which we could use as a quarter, but there's no 2 there, so it can't be 2 quarters. Can we see what it would be? Look at those numbers, look what's up there. Yeah? Did you get it? Would have got 3 6. Yeah? 3 6 is the same as half. And if we look at how many 3s are in 6, there are 2 of them, and that's why it's half. Yeah, right, now let's look at Danny's problem. Danny uses 4 of his cards to make 2 equivalent fractions. How could Danny complete his puzzle? He's got 1, 2, 3, 4, 5, 6. Let's have a look what we can find out for Danny. So there's more than one way of solving fraction problems, as you know. And he has used his multiplication tables to help him solve his. So if we've got half there, we can see that if we times 1 by 3, we get 3. And then if we times the 2 by 3, we get 6. So half is the same as 3 6. It's equivalent to. It's equivalent to the same. Works with any fraction, as long as you do what you do to the top, the numerator, you also do to the denominator by the same amount. You must always times it or divide it by the same amount. So there we have got 2 times 2 is 4, 3 times 2 is 6, which will give us 4 6s is the same as 2 3s. And if we look at thirds, we times it by 2. 1 times 2 is 2. 2 times 3 is 6 to give us 2 6s. So can we see we could use all of those numbers there? 1, 2, 3, 4, 5, 6. We could use 1, 2, 3, 4, 5. Where's the other one? 6. Yeah, can we see how that works? We could actually, don't forget, divide them. Works the same, so long as what you do to your numerator, you do to your denominator. 4 over 6, so 4 6s. If you divide that by 2, you get 2. If you divide that by 2, you get 3. So that is the same. It works out the same. So that's a good way. I always do my fractions that way. But if you are not sure with your multiplications and you forget, use that fraction line or a number line to help you. Let's look, thinking together now. We've actually got our fraction line. So the numbers 1, 2, 5 and 10. And there are my numbers. Can we see them? 1, 2, 5 and 10. And all there waiting to be used. Now we've got to find a pair equal fractions. Can we see equivalent fractions got to equal the same amount? So that's my equal sign to remind me. So if I use a line again, I can see I'm going to use half because half's on my line and I've got a 1 and 2 there. I can use 10 and 5 now. So let's have, we've got 5. Won't be fifths, will it? Can we see why not? It could be 5 tenths. Could be 5 tenths. Can we see why that would be? Got a 5 and 10 there. That would be equivalent to the same. How many 1s are in 2? 2. How many 5s are in 10? 2. And that's why they're worth half. So that will be 5 tenths is the same as half because there are 2 lots of 5 in 10. What about making some more equivalent fractions with the same number, different equivalent fractions? Let's think about what numbers look on my fraction lines, my number lines, to help me which two match up. Oh, look, those match up. 4/5 and 8/10, because 4 and 4 is 8, 5 and 5 is 10. But I've not got a 4 there or an 8 there, so I can't use that. What about this one then? 3/5 and 6/10, because 3 and 3 is 6 and 5 and 5 is 10. So they would be equivalent, but I've not got a 6 there. So if I go here, will this one work? Oh, no, because I haven't got a 4 there, can we see? So what about this one? 1/5, 1/5 and 2/10. Can we see why that would work? So you've got to check all the possibilities, and then we know, don't we, that that would be the same. If we look, make sure how many 1s are in 5, 5 of them, how many 2s are in 10, 5 of them. Can we see how that works? So let's look at number 2. Right, the missing numerators and denominators for these equivalent fractions. So can we see that we're missing some numerators and some denominators? So you can use a fraction wall to help you. Now, you might not have a fraction wall that's got 5ths and 10s, and you don't want to make one or anything, but if you've already got one that's been made, you might use it just to jog your memory. So I'm using this just to jog my memory of what I'm doing. So I'm looking at maybe what will be equivalent to 1/3. So I've got 1/3 there, and I can see there, if I put my arrow all the way, it will be join up the same line as my 2 6s. So 2 6s equals the same as 1/3. And I can see what's happened to my numbers straight away. If I divide 2 by 2, I would get 1, wouldn't I? 2 divided by 2 would give me 1. And I've halved it, haven't I? I've halved the number. If I've got 6 and I divide it by 2, I get 3. So again, we can see that that is double. That's a 1/3 is double 2 6s. 2 6s is actually half of that number, isn't it? I've halved them. So I'm using that in my head now to remind me to do these. So I know that my 5ths have gone to 10. So as numbers got bigger, and that's doubled, so it's times it by 2. So if that times by 2, this has also got to be times by 2. So my 2/5 equals the same. It's equivalent to 4/10. If I look at my 3/10 now, sorry, my 3/10, I know my 3 has gone to a 6, so that's also doubled times by 2. So this one's going to be a big number, isn't it? 10 times 2 would give me 20, so that would be equivalent to that. If we look here, my number's actually got smaller. It's got smaller, so I've had to divide it by 2. 10 divided by 2 gives me 5. 8 divided by 2 would give me 4. So 4/5 is exactly, well, not exactly the same, it's equivalent to 8/10. So now I'm looking what equivalent 6/8 is to how many quarters. How many quarters would it be? So I can see that the 8ths has been divided by 2. So I've also got to divide this by 2, which will give me 3. Yeah, can we see? Yeah, and if I doubled that, 3 and 3 is 6, 4 and 4 is 8. So we always got to remember what we do to the top number, to the numerator, we've also got to do to the denominator. Even if it means dividing or subtracting, we've still got to do the same. Let's look at the challenge then. Remember, you're only doing the challenge if you're finding the maths relatively easy. It is in your emails. You might not need to print it out. You might just want to write it in your book. Max and Jamie are trying to find the missing number. So he's got 6/10 equals the same as what? 5th. And Max says, I multiplied 5 by 2 to get 10. So I need to find what number I multiplied 2 by to make 6. That number is 3. So is he right? Yeah. Let's have a look what Jamie says. I divide 10 by 2 to get 5. So I need to divide the numerator 6 by 2, which gives me 3. Is he right? Yeah. Do both Max and Jamie's methods work? Which method do you prefer? So it's asking you there, use Matt's or Jamie's method to find the missing numbers. Let me see what they're saying. Yeah. Right, see how you go on with that one. And your work today is in page 12, your work starts. And don't forget, all have a go at the reflect. The reflect says, explain why 410 is equivalent to 2/5. You've got to explain it in words, yeah, not just showing it in numbers, in fractions, explain it in words. And I shall see you tomorrow. Bye.